What's up guys, I'm DJ Baikan from the College of Engineering Education. In this video, let's discuss about the apportionment, the Huntington-Hill method. The Huntington-Hill method was developed by Edward Huntington and Joseph Hill. Huntington-Hill method also is similar to the Webster method, but attempts to minimize the percent differences of how many people each representative will represent. And this is our procedure of Huntington-Hill method. Number one, determine how many people each representative should represent. Do this by dividing the total of the population of all states by the total of the representative. And this is called the standard divisor. Let's say we have 750 divided by 50. So 750 divided by 50 is equals to 15. So this is our standard divisor. Second, divide each state population by the divisor to determine how many representatives should have. Record this answer to several decimal places. This is called the total. So let's say we have 70, 80. So this is our representative for the population of people. So 70, we have standard divisor. So 70 divided by 15 is equals to 4.6666, and 18 divided by 15 is equals to 5.3333. So this is our quota. To find the lower total, sorry. Let's proceed to the next step. Step 3. Cut off the decimal part of the total to obtain the lower total. Let's say the total is n. To find our geometric mean, compute the square root of n times n plus 1. So, to find our lower total, let's say this is our quota. So, to find the lower total, let's cut off the decimal point to this. So, this is our lower total. So, to find the geometric mean, so let's say square root of 4 times 4 plus 1 is equals to 4.4721, and square root of 5 times 5 plus 1 is equals to 5.4772. So this is our geometric mean. So step 4. If the quota is larger than the geometric mean, round off the quota. But if the quota is smaller than the geometric mean, it will be same. And this is called the initial allocation. To find the initial allocation, let's say this is 4666 and 5666. This is our quota. This is our geometric mean. This is our lower quota. This is the geometric mean. So in this, our quota is larger than the geometric mean. So let's say round up. Let's say this quota is 4, but let's say 4 our quota, so we say 5 because the quota is larger than the geometric mean. Here also the quota is larger than the geometric mean, so 6 because if the quota is larger than the geometric mean, round up the quota. So and this 2 is the initial allocation. And let's proceed to the fifth state. If the total from the initial allocation is is less than the total number of representatives with those that the advisor and the calculate the quota and allocation. But if the total is larger, it increase the divisor and calculate the quota and allocation. Continue doing this until the representative, and that's called the modified divisor. And I will give you some example. Say, my number one example. Say, the Santa Cruz National High School offered tutoring in science, math, PE, and English. The number of the students in science is 380, math is 240, PE is 55, English is 105. The Santa Cruz National High Schools can only afford to hire 31 tutors. So, let's write the students enrolled, science, and the total is 780. So, to find the standard divisor, let's divide the 780 and 21 tutors. So, we have the standard divisor of 37.142. And this is our total. To find this, let's divide this by 37.142. 380 divided by 37.142 is 10.2307. And 240 divided by 37.142 is 6.4615. And 55 divided by 37.142 is 1.4808. And 155 divided by 37.142 is 2.8269. Find our total. This got this. So our total for science is 10, math is 6, PE is 1, English is 2. And to find our geometric mean, so square root of 10 times 10 plus 1 is equals to 10.4881. This is the geometric mean of science. And the geometric mean of math is square root of 6 times 6 plus 1 is 6.4807. And thus, to find the geometric mean of PE is square root of 1 times 1 plus 1 is 1.412. And that's our geometric mean of the PE. In English, square root of 2 times 2 plus 1 is 2.449. And that is our geometric mean. And to find our initial elevation, just like I said before, if the quota is larger than the geometric mean, let's round up. If the quota is lower than the geometric mean, it will be same. So, as you can see this, the geometric mean is larger than the quota, so our initial amount of science is 10. And the initial allocation of math is 6 because the geometric mean is larger than the quota. And the theory is 2 because the quota is larger than the geometric mean. And our allocation in English is 3 because our quota is larger than the geometric mean. And at the allocation of 21, so our initial allocation is 21, so this statement is correct because our 21 tutor, this is the 21, so 21 is our representative or the school that currently afford. And next, our second example. Let's say there are event and barangay attending by 4 for the event. And these are, and there are 20 seats that the barangay should represent. So let's say our first purot is consists of 125 and second purot is consists of 86 and third 77 and 125. So the total of the amount is 393. So let's divide the 393 divided by 32. So our standard divisor is 12.28. So let's divide this by 12.28. So 155 divided by 12.28 is 10.1791. And 86 divided by 12.28 is 7.003. And 77 divided by 12.28 is 6.2704. And 105 divided by 12.28 is 8.5565. And our lower quota is 10, 7, 6, and 8. So, to find the geometric mean, let's say this square root of the lower quota times the lower quota plus 1. And that's the result of the geometric mean. So 10 square root of 10 times 10 plus 1 is 10.4881, and square root of 7 times 7 plus 1 is 7.4833. So let's total is by the square root of itself. And to find the initial allocations, let's talk about this. That geometric mean is higher than the quota, so it's 10 because geometric mean is higher than the quota. And the geometric mean also in group 2 is higher than the quota, so it's 7. And the geometric mean in the group 3 is higher than the quota, so it will be the same, 6. And the geometric mean in the group 4 is lower than the quota because the quota is higher than the geometric mean, so 8. Let's add 8 plus 1 equals to 9. And add this, 10 plus 7 plus 6 plus 9 is 32. So we have the correct situation because 32 and 32, 6. That's correct. And let's proceed to the third example. This is the third example. The dictate dividing the teacher between each 5 schools. The dictate can only have 175 teachers. So let's say in the first school we have 875 teachers, and the second school we have 1,150. The third school we have 1,200, and the fourth school we have 725. And the fifth school we have 925. And let's add all this in the total of 4,875. Divide this by the 15 can only have 75. So 4,875 divided by 175 is equals to 27.86. So that's just what I said before. This divide all of this divide the standard deviation, and the quota, and the result will be the quota. So let's visit the initial evaluation. So we say this geometric mean is higher than the quota, so it will be the same. The geometric mean also is higher than the quota, it will be the same. And here in 3, the geometric mean also is higher than the quota, it will be the same. And 4, the geometric mean is higher than the quota, it will be the same. And 3, the geometric mean is higher than the quota, it will be the same. But as you can see, the total of this is 174. Now, is not same as the defeat cannot be hard. So to become this as 25, it's quite a modified divisor. So we have to write a modified divisor. So we have 5 modified divisor. So I'll write 27.75 weight. So as you can see, the total of the 100, the total of before this is 174. So it will lower than the representative. So as you know, if the lower of the representative, it will be round down. So let's minus this to this. So we have a 27.75. So let's divide all of this with 7.75 and we'll have the quota, the new quota. So as you can see, the geometric mean, this is lower than the quota, so it will add 31 plus 1 is 32. Before, the quota is lower than the geometric mean, so the 31. But in this, the quota is higher than the geometric mean, so we have 32. And this is all the initial allocation. If you have 32 plus 41 plus 43 and 43, 26 and 33, we have 175. So 175 is the same as the defeat that only had 175 picture. And let's put it to the number 4 example. Number 4, a country with 5 states and 58 states is income less and population distributed as in the table below. So this is our A, 59, B, 89, 98, C, 150, D, 104, and E is 55. And the total of 466. And 466 divided by 50 is equals to 8.03. And divide all of this by 8.03 to find our quota. And this is our quota. And to find our lower quota, let's just like I said before, part of the decimal point. So we have 7, 12, 18, 12, and 6. So to find our geometric mean is we use the square root of n times n plus 1. This n is our lower quota. So as you can see, the geometric mean is higher than the quota. It will the same. And here in the geometric mean also is higher than the quota. It will the same. And C, the geometric mean is lower than the quota. It will 18 plus 1 is 19. So in D, the geometric mean is lower than the quota. So 12 plus 1 is 13. And the geometric mean here in A is lower than the quota. It equals so 6 plus 1 is 7. And add up all this is equal to 58. And we have the correct answer, 58, because the country with 5 seats, 58 seats, and the other denominator is 58. And let's proceed to my last example. Say 5. There are 5 regions and only 25 seats that the region have. And the first region have a total of 1,820 people, and 89 people. And the second region have a total of 976 people. The third have a 589, and the fourth have a 1,500, and the fifth have a 596 people. And here, region 1, region 2, region 3, region 4, and region 5. Add all of them and equals to 5,550. And divide by 25 because there are 25 seats. So 5,550 divided by 25 is equals to 2,222. So to find our quota, it's all this divided by 122. So region 1 is 1,890, 890, 889 divided by 22 is equal to 8.5090. So this divided by this, and this is their quota. So to determine our quota, it's that of the decimal point. So we have 8, 4, 2, 6, and 2. And our geometric mean is square root of 8 plus square root of 8 times 8 plus 1 is equal to 8.4853. And it's all have this to find our geometric mean. That's our formula to find our geometric mean. So our initial allocation and region 1, the geometric mean is lower than the quota. So 8 plus 1 equals 9, and our geometric mean is higher than the quota, here we say. In region 3, our geometric mean is lower than the quota. So 2 plus 1 is 3. Our geometric mean in region 4 is lower than the quota. So 6 plus 1 is 7. And in region 5, our geometric mean is higher than the quota. So lower than the quota, 2 plus 1 is 3. And other of them is 26. But as you can see, it is 26. This is not the same as the seat given. So we have to find out modified divisor. So our modified divisor is if the initial allocation is higher than the given, so let's increase the divisor. So from 222, let's increase to 223. So all of them will divide by 223, and this is their quota. So their quota and geometric mean is the same, but their quota is not. So as you can see, the geometric mean here is larger than the quota, it will be same. And geometric mean here in the region 2 is larger than the quota, it will be same. And region 3, the geometric mean is lower than the quota, so 2 plus 1 equals 3. So in region 4, the geometric mean is lower than the quota, so 6 plus 1 is 7. And the geometric mean in the region 5 is lower than the quota, so 2 plus 1 is 3. So all of them is equal to 25. And this statement, modified divisor is correct because we have the 25 initial allocation. So the 25 seat is same as the initial allocation. And that's all. Thank you. I hope you have learned a lot from this video.